This is Walt Miner here at Embedded World 2020. I am the Automotive Grade Linux Community Manager, Development Manager, and just a quick introduction of Automotive Grade Linux. We're a collaborative project under the Linux Foundation, completely open source project. We have 155 overall member companies, including 11 car manufacturers and a number of open source, a number of tier 1 suppliers that they use. There's these auto manufacturers such as Toyota, Suzuki, Mazda, Mercedes-Benz, Volkswagen are specifying automotive grade Linux to be used in their upcoming vehicles. We can show you here a demonstration of the open source software using our famous Green Machine demo, and introduce my colleague here, Jan Simon Muller.
Hello, I'm Jan Simon Muller, and I'll show you the demos that we have here at the booth. First, in the middle, we have our main demo, which shows what AGL looks like right now. We have here the infotainment side, which is radio, HVAC, media player, and navigation going on here. Here we have the instrument cluster, speedometer. We have also the steering wheel controls integrated here, so we can completely do the cruise control. We can change the volume with the steering wheel. That's all integrated. You can hear the navigation sound output.
What kind of chipsets are running?
What kind of chipsets? So this demo runs on a Renesas R-Car Gen 3 chip. And the cluster is actually running on a Raspberry Pi. Yeah. So what you see right now, that's the R-Car Gen 3 on the Kingfisher baseboard.
So this is ARM Cortex
That's a 64-bit ARM chip, 8-core, big little setup, and the cluster is running on a Pi 4.
Is there a lot of Linux in cars?
It is. So AGL is in production for a couple of car vendors. So Toyota has a couple of models running AGL. Then we have also Subaru that has it announced, and that's currently in production. Over here we have a demo which brings both systems on one single board, and they are using containers to make that happen.
What is this board?
That's also the R-Car with the Kingfisher baseboard. So it's the same baseboard, but instead of using two boards, we use one board, and both applications here are in separate containers. And as you can see, if one container is basically resetted, it is instantly available again.
What's the big challenge? It's a big challenge to do automotive grade, no? So is it to do with the reliability, security, speed?
Yes.
What is it?
Yes. Reliability and security are important topics. The AGL has security extensions built in, because we think that you cannot just attach security at the end. So we have a security framework active, and we have access control to our APIs built in, and that's what's special about AGL over a standard off-the-shelf Linux system.
How much Linux is there in automotive thus far? Are many of the systems using other OSs? Many of the cars out there?
There is Linux used in the car. at different functions. With AGL, we are exploring how to use it in different use cases within the car, ranging from infotainment to cluster to telematics, even down to autonomous. So even
is
autonomous
most of it today
systems.
is infotainment?
Infotainment, cluster, telematics is what we have in the code base, but the platform is capable of supporting also further use cases.
But most deployed cars in the world
It's
are just in
infotainment.
infotainment for
Yes.
now,
Yes.
right?
Infotainment.
To get into this area is a big deal.
Yes.
To get in all the other.
Yes. Yes, and there's work to do, of course.
So what's the big challenge now?
The big challenges are to reach functional safety. The goal for the project is to provide the platform basically an 80% starting point of the final product, and the goal is to reach ASIL B with the platform.
B. What does that mean?
There are multiple levels, and for automotive there are ASIL A, B, C, D, and for AGL the target is ASIL B.
What's the difference between A, B?
I'm not.
A is higher.
No, D is higher. D is the highest. D
yeah.
is the highest.
So what are we looking at here?
Okay, here you see AGL even runs on a Raspberry Pi 4, so if you want to try it out at home, get a Raspberry Pi 4, go to our website and you can download the ready image. It also works on kind of more production-like hardware. So this is, for example, a BeagleBone Enhanced over here, which is a nice telematic device. Or it also works on an up-square board.
So that's
And
stuff.
everything uses the same code base. It's exactly the same code base.
Same code base. How about the graphical user interface? Is there a lot of different options out there, or what do
So
people do
right
for
now
that?
you have two options. What you see here on display, this is our QML demo UI, but you can also do HTML5, but we don't have that on display right now.
What's happening here?
So over here, that is AGL tailored towards a boat system. So for driving a whole boat setup.
So it's boat grade Linux.
Basically, yeah.
So how is it possible to take what AGL is doing and take it over to the boats?
So AGL itself is all open source. So the foundation, the platform is all open source, and here we see an implementation that's capable of driving the boat-related systems. I mean, in the end, they also use CAN bus, so the interfaces are very similar.
And what is there? Bunch of
I think
small
that's
boards.
the simulators for the navigation here.
And here? It's more.
So
different
this is a navigation system, an open source navigation system for boats.
So when you look at all the cars, most modern cars right now in the market, what are the leading OSs that people use, in not in the infotainment but in the other parts? It's a bunch of different.
Well, soon AGL, of course.
AGL, but the other ones are like RTASs or.
Yeah, right now there are a couple of RTOSs out there. Right.
Very popular, and here in Germany there's a few car companies, right? So they're probably very busy working in this in Germany.
Yes, so we have Daimler being active in the project, and the whole VW group working on AGL. Yeah.